Hi, my name is Stephen McGee and I'm the author of Toxic Electricity. I'm here today to talk about the David Blaine Electrified experiment that we've just seen a few days ago. And one of the things that I noticed with this particular experiment is that everybody who was speaking about the sparks, they were saying that they're high voltage but they're low current, and the low current makes them harmless. And I don't actually agree with that theory. I think you have to talk much more in terms of power, because that's what electricity is, and power is a measurement of the energy in the spark. So all sparks have voltage and current associated with them, and power is basically the voltage multiplied by the current, and that is measured in watts. So when you've got high voltage and you've got low current, you multiply them together, you get medium power. So there's a lot of power in that system. And based on what we know regarding those sparks, is we know they were probably maybe around 5 million volts, because those Tesla coils were probably about 5 meters away from him. And you need about 1 million volts per meter to push electricity through air. So over 5 meters, you'll need that 5 million volts to get it to cross that gap. And you need a lot of power in the system to do that. And you got to kind of wonder, if it was maybe a milliamp of current in there, it gives you a lot of power if you've got 5 million volts, because you multiply the voltage by the current. It's my estimation, based on the brightness of those sparks, that they were probably in the range of maybe between 5,000 to 50,000 watts. I'm not too sure. I never really heard anybody speak about power regarding the sparks that were hitting him. So, that's a lot of energy to be hit by for basically 72 hours or 3 days and 3 nights. So there's a lot of power in the system, there's a lot of high voltage, and there's definitely current and frequencies. And to protect himself against that dynamic, he put on this Faraday suit. And basically he was getting hit by electromagnetic pulses from lightning bolts, and lightning has electromagnetic emissions associated with it. So by association, they hit his suit, so that means his suit has voltage, current and frequencies flowing through it. It also means that the grounding system that the suit is connected to has the same emissions. So something that when I was watching the people talk about his suit, the so-called experts, I think the big thing that they were missing was the fact that these Faraday suits don't fully protect against every single emission. And there were many emissions coming from those lightning bolts. So it may have been working well in some areas, and it may have been working extremely poorly in others. So let's move on to the grounding system. So this is what he was relying on to protect himself. So over here on the left, we actually have what we saw on TV. So it's the circuit that we saw the Tesla coils. They were firing out sparks, they were hitting the suit was going into the grounding system and flowing around back to the Tesla coil. So if you redraw the circuit, you get this, and there's our Tesla coil providing the current to flow through the resistors in the circuit. And if you look down here, we have the grounding system, and that's what happens when you feed current into a grounding system that has multiple ground rods on it. You'll start getting current flowing through both the actual physical ground and also the cable, copper cable or aluminum cable ground. So it splits into two. So the current will be flowing around the circuit, and that current had frequencies associated with it. And the higher that current is, the higher the voltage gets in the circuit. So the voltage on his suit probably wasn't actually at ground potential, it was probably something higher because of the resistance in the circuit. And it is kind of concerning that I haven't really seen anybody do an analysis on this suit and the grounding system before they ran the experiment. So if anybody has that data, I'd be interested to take a look at it. So the big thing about pushing current around grounding systems is that the voltage on grounding systems can go up and down with the load. And it pretty much is dependent on what's going on at the time as to what the voltage will be. So I'm going to talk about Faraday cages and Faraday suits. So if you're going to build these Faraday cages and Faraday suits, something to be aware of is the Faraday cage is the best way to go. So you want the person in the middle of the cage, and you don't want them near the sides of the cage or the bottom or the top. You want a big gap between the person and the cage so that there's no biological coupling taking place. So the spark will come in, it'll hit the cage, and it'll completely bypass the person and go into the grounding system. So there's no current flowing through the person. So he had the lesser version of the Faraday cage, and that's the Faraday suit. So a bolt of lightning comes across, hits the suit, flows through the suit into the grounding system. And I'm not even sure whether he was actually insulated from that suit. I haven't really been able to establish that by the data that's on the internet regarding this experiment currently. But this is the poor man's Faraday cage. If you're going to try and shield yourself, you want the cage. That's the better option. So he's had currents, voltages and frequencies flowing very, very close to his skin for 72 hours. And I'm very, very curious to see how his health is going to be over the following weeks, months and years from exposure to this. And I really hope that he's okay. And I'm looking forward to seeing him reappear and tell us all about the experience and tell us about any health problems that have shown up so that we can research this and publish it in books for the next generation. I hope that you enjoyed this presentation, and I wish you the best of health. Thank you.